Hey guys, I'm Mr. Mills, and today we're going to be solving inequalities, and we'll be doing this both with absolute values in there and also without absolute values in our equations. Okay, so if you can recall, inequalities, a lot of times that's when we're going to have two different answers, and by that I mean we'll have like x is greater than 2 and x is less than 6, or we might have, I don't know, x is greater than or equal to -5, or x is less than -20, or something like that, right? Well, we're really going to have two different answers a lot of the times. Not all the time, but a lot of the times, right? And so what I did over here is I wrote down different ways that we might have and statements, meaning we'll have two different answers, and they will be combined with an and, meaning an intersection. And over here, two different examples of when we would have or statements, meaning we'll still have two answers, however, we won't take the intersection of them, we'll take the union of them, right? And then lastly, I have the third option would be neither an and or an or. This one right here would only get us one answer, right? So no intersection, no union, nothing. It's just, hey, x is less than 5 or whatever, something like that. Okay, so these will get us two different answers, right? Each. These will get us two different answers each, and this guy will get us neither. Okay, so what I would do is I would pause this video and write down all 5 of these inequalities, and then I'll talk about each one, why it is an and or an or neither. Okay, so this first guy here, so 8 is less than 3x minus 7, less than or equal to 23. This guy is an and statement, and I know that because it has two inequalities in it, all on one line. All on one line, and that's the key part, right? So since this is all on one line, and it doesn't say the word or in there, then I know this is really two different inequalities. I need 8 to be less than 3x minus 7, and I need 3x minus 7 to be less than or equal to 23, right? So this guy's going to get me two different answers. This guy here, this absolute value of 5x plus 2 is less than or equal to 17. Remember, whenever I have a less than, I always think less than, right? So this means and right there. Whenever I see that, less than, okay? And then over here I have x plus 6 is less than 4, or 3x is greater than or equal to 14. Well, right away in the problem, I have an or written there. Okay, so that's guaranteed to be an or statement. Okay, and then also I have 2 times the absolute value of 6x minus 5 is greater or equal to 26. Okay, so this greater, that's what I was thinking in my head, greater, right? So this is going to be, whenever I see absolute value is greater than something, that means I'm going to get an or statement, okay? And then lastly, on this neither one, well, I don't have any absolute values in there, right? And I only have one inequality, right? And so because I have no absolute values and I only have one inequality sign, that means that this is not going to be an and or an or. It just means, hey, solve this inequality like you would any other equation, right? You don't got to split it up into two problems or anything like that. It's just solve this inequality like it's a regular old equation. That's it. Okay, so I'm going to go ahead and take a couple of these and solve them. First, how about I start with I'll do this one, this 8 less than 3x minus 7 less than or equal to 23. Okay, so I'll do 8 less than 3x minus 7 less than or equal to 23. Okay, so I'm going to go ahead and solve this. And like I said, I know that this must be an and I know it's an and because it's all written on one line and there's two different inequalities in it. Okay, so I'm trying to think, what are my two equations? Well, I really have two different things. I have this part of the expression right here. I have 8 is less than 3x minus 7. So that's going to be one of them, 8 less than 3x minus 7. Okay, and then I also have, on another equation, I have this, this 3x minus 7 is less than or equal to 23. 3x minus 7 less than or equal to 23. Okay, and so I really have two different equations going on here, inequalities. Right, so I'm going to take them step by step, and I'm just going to solve them both independently. So I'll start by solving this 8 less than 3x minus 7, right? And so trying to get x by itself, so maybe I'll add 7 to both sides. And then when I add 7 to both sides, I get 15 is less than 3x. Okay, and then I also need to divide by 3 to everything. When I divide by 3, I get x is greater than 15 divided by 3 is 5. Boom. Okay, this is 100% correct. Usually we write the x on the left side of the inequality. So I'm going to write this as x is greater than 5. Notice how in this expression right here, the x is on the open side of the sign. And then down here, x is still on the open side, right? So these two are saying the exact same thing. But usually we write the x to be on the left side. So I'm going to write this as x is greater than 5. And now over here, I'm going to solve this one the exact same way, just trying to get x by itself. So I'm going to go ahead and start by adding 7 to both sides. So plus 7 plus 7. When I do that, I get 3x less than or equal to 30. Okay, and then I'm going to go ahead and divide by 3 to both sides. So I get x is less than or equal to 30 divided by 3 is 10. Okay, and so I really have my two different answers here. I have x is greater than 5, and I also have x is less than or equal to 10. I really only have one more thing to do here, and that's to graph my two solutions on a number line to kind of see where they're at. So I'm going to go ahead and make a number line here. I usually start by putting 0 on there. And then I'm going to have to go all the way up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 3, 4, 5. So this is 5 right here, and this is 10. I'm going to have to do x is greater than 5. Okay, so I'm going to go ahead and mark my first point at 5. Now remember, since this is strictly greater than, meaning there's no line underneath, that means it's not equal to, which means it's going to be an open circle. Okay, so open circle. Okay, so x needs to be greater than 5, so everything that's bigger than 5. So the greater than side, I'm going to go to the right, because we're going greater than. And then next, I have x is less than or equal to 10. So I know my point is going to be at 10. And since this one is less than or equal to, that means I'm going to need a closed circle here at 10. And since it's less than, that means I'm going to go to the left because it's less than 10. Okay, and then so my final answer is, hey, remember, this is an and statement. This is an and statement, so it needs to be greater than 5 and less than 10. So I'm just looking at the intersection, and that is my final answer right there, the intersection. And I'll even write that down here. I'll write that my final answer is x is greater than 5 and intersection, x is less than or equal to 10. And this is my final answer here. If you wanted to combine that onto one line without using the intersection, you very well could. However, I think this is pretty sufficient for Algebra 2. Okay, and so that's a nice example of using an and inequality. Now I'm going to go ahead and erase my beautiful work, oh no, And I'm going to work an OR inequality. Okay, and I'm going to go ahead and pick this guy right here, this 2 absolute value 6x minus 5 greater than or equal to 26. Okay, so how about 2 absolute value 6x minus 5 absolute value greater than or equal to 26. Okay, now remember, before I do anything, I need to get this absolute value by itself. Okay, so to start the problem, I'm going to go ahead and remember to divide everything by 2. When I go ahead and divide everything by 2, I get the absolute value of 6x minus 5 is greater than or equal to 13. Okay, so now I'm good to go ahead and start and identify, is this going to be an AND or an OR inequality? Well, because this is absolute value greater, that greater than sign means, hey, this is going to be an OR inequality. Okay, so this is going to be an OR. So let's go ahead and split this guy into 2 different inequalities. Let's go ahead and split it. Okay, and so one of them is going to be 6x minus 5 greater than or equal to 13. Okay, and then the other one is going to be 6x minus 5 is, because I'm splitting it into 2 different equations, it's kind of like when you divide by a negative with inequalities. I'm going to flip this sign down here. So instead of having greater than, I'm going to have less than or equal to 13, negative 13. Right? And so I make this negative, and also I flip this sign. Now, beyond this, it's basically just solving 2 different inequalities. So how about with this guy, go ahead and trying to get x by itself because x is an introvert. So let's add 5. So I get 6x greater than or equal to 18. And then let's go ahead and divide by 6 to both sides. So I get x greater than or equal to 18 divided by 6 is 3. Okay, so that's one of them. And then over here, same thing. I'm trying to get x by itself. Let's go ahead and add 5 to both sides. So then I'm going to get 6x less than or equal to negative 13 plus 5 is negative 8. Yeah, and divide by 6. I get x is less than or equal to negative 8 over 6. And if I'm reducing that fraction, I get x less than or equal to negative 4/3. Okay, so I really have 2 different answers here. I have x is greater than or equal to 3, or x is less than or equal to negative 4/3. Okay, so my last step is, hey, let's throw these things on a number line. Again, I like to put 0 right in the middle. 3 is somewhere over here, so 1, 2, 3. This is 3. And then negative 4/3. This is negative 1, negative 2. I'm okay with you guys just estimating where negative 4/3 is. Okay, so I'll start by doing this x is greater than or equal to 3. So x is greater than or equal to 3. Well, I'm going to need a point at 3. Okay, and then since x is greater than, I'm going to go to the greater than side, which is to the right, everything that's bigger than 3. Okay, and then let's not forget, since this is or equal to, that means I'm going to need a filled in circle. And then lastly over here, x less than or equal to negative 4/3. Negative 4/3 is like negative 1.3 as a decimal. So I'm going to need a point just past negative 1. And then remember, since this is or equal to, that's going to be a closed circle. And then lastly, it is less than negative 4/3. So I am going to everything that is less than negative 4/3. So my final answer is either in here or it's in here, one of the two, right? Because this is an or statement. So final answer is x greater than or equal to 3, or, meaning union, x less than or equal to -4/3. Done. I understand the inequalities. The and or statements can kind of get a little confusing. So I would look at these 5 inequalities that I have shown here and try to match them up when you're doing your work. Try to match them up like, hey, does this look like an and? Does it look like an or maybe it's a neither? Right? Okay. That's all for today. Thank you.